Welcome everyone to this webinar on Industrial Control System Cybersecurity Assurance. I'm Bob Quigler. I'm on staff at ISCI, the ISA Security Compliance Institute. We are very fortunate to have Graham Speak and John Cusimano on our presentation today. Unfortunately, Ed Crawford was unable to join us, but he'll respond to questions if you have any on end user and security issues. Graham is Principal Systems Architect at Yokogawa Electric. In his 30-year career, he spent the last 15 years in industrial cybersecurity. He's co-chair of the International Group for Industrial Control Systems Joint Working Group and an editor for ISA 99. John is Director of Exeda's Security Services Division. He led market development for Siemens process automation and safety products. John is a recognized process automation safety and security expert with more than 20 years experience. Now I'd like to turn it over to them for the Industrial Control System Cybersecurity Assurance webinar.
Thanks, Bob. This is John Cusimano. Before we get started, we did want to ask the audience if you would please let us know a little bit about yourselves in terms of what best describes your organization, or at least your role in your organization. Are you with an asset owner, operator, automation system supplier, system integrator, academic institution, so on? And the votes are coming in. Let me just let everybody see the results here, which are still being tallied. And starting to stabilize as a lot of people do seem to appear to be just joining the call still. So. But as you can see here, we're about a quarter of us are asset owner operators, another almost the same for automation suppliers, a little bit less, and about another quarter consultants, and the rest fall into some other categories. So thank you for letting us know that. I'm going to go ahead and close the polls and get started on the webinar. Before we get into some of the details of the ISA Secure program, I want to talk a little bit about just what's going on in the world of security incidents and share some data from the Security Incidents Organization that operates the RISI database. Just to give you a feel for when you look at the actual security incidents out there over about a 10-year period, you see that about 80% of them are actually unintentional. 20% are intentionally caused by either a hacker or unauthorized individual getting into the control system to deliberately cause some damage, or a disgruntled employee doing the same. However, the other 80%, although unintentional, still cause the same types of incidents in terms of lost production, downtime, equipment damage, and even been cases of injury and death. Those break down into three categories. About half of those are caused by software bugs in the actual control system products or networking equipment. Another 35 or 40% are caused by malware getting into the control system through some unintentional means, but finding its way into the control system. And lastly, there is well-intentioned employees that accidentally cause security incidents. A typical example might be IT department or technician troubleshooting a network and scanning it or sending malformed packets or broadcast storms that might cause a problem on the network. There's lots of examples of incidents that have occurred over the years. Just to give you a few of them, Here's an example where an antivirus software update on a computer in a control system actually caused the safety system to be able to fail to perform its safety function, basically holding it in a state where the system was unable to respond to a shutdown event. Here's an example of a case of multiple PLCs that were crashed by an IT security audit. Again, here, a well-intentioned security consultant was brought in to check out the networks, and in the process was sending the types of probe packets and scans that would be normally done on an IT network, but unfortunately, industrial control system Ethernet-based equipment is not as resilient, and in this case, it caused a number of PLCs to hard fault. One more example of, as I said, many out there. Here's an example where a virus infection from a rather generic piece of malware called PE-Sality. That virus got into a control system and particularly into two OPC servers that were important for maintaining communications between the control system and the safety system and the electrical controls. Both of those went down, causing the operators to be blind and not have data from or the ability to communicate to those systems for over 8 hours, while engineers at the facility had to rebuild those machines. So I'm sure everyone here has heard of Stuxnet and DuQ and Flame and a variety of industrial control system specific viruses that have been emerged over the last couple of years, and may even have read some of the recent stories in the newspapers about the origin of those viruses and how they have been used in a number of different means. We're not going to talk about Stuxnet particularly today, but we did want to talk about the reaction or the impact it has had on control system security. One is it's provided a proof of concept, or some might say a blueprint for other people to copy or reuse that code for also for malicious purposes. Number two, it's really raised the attention level of corporate executives and regulators and even the general public on the potential danger of cyber attacks on critical infrastructure. And recent stories even have people concerned about the possibility of retaliation on U.S. Critical infrastructure. And one other interesting impact of Stuxnet is it really has opened the floodgates, if you will, or raised the attention level of security researchers who have as a business, identify and exploit ICS control system vulnerabilities. And there have been numerous reports of security researchers who have discovered control system security vulnerabilities and published their results very publicly. One of the most recent and interesting was from the S4 conference and something called Project Basecamp, where 6 researchers took 6 products and publicly released their findings. This graph here shows just the number of security vulnerabilities that have been reported over a 10-year period, but you can see the dramatic increase in 2011, and that is primarily from this effort of security researchers who have focused their attention on control system products. As I mentioned, there was an event in January of this year called Project Basecamp with these 6 researchers who focused on 6 different embedded control products to study their vulnerabilities. And they found numerous issues and, as I said, published their findings in a very public forum and published Nessus plugins, which are scanning tools that are readily available to find these, and Metasploit modules, which is an exploit tool which would allow really a novice to be able to download these exploits and test them themselves. All of this creates concern about the security vulnerabilities in the control systems used in critical infrastructure. And it's well agreed that while the end users have the ultimate responsibility for the security of their control systems, there are multiple layers of responsibility in different organizations that must come together and work together in order to truly secure our infrastructure. So there are the system integrators, the automation suppliers, and even the products themselves. And this is why we asked who was on the phone today, so we can understand that really everyone plays a role in securing critical infrastructure. So the situation today really is that control system products have evolved pretty rapidly, at least starting in the mid to late 1990s till now, to have moved from rather closed proprietary technology to very open, what we call commercial off-the-shelf technology, or COTS, moving from proprietary networks to open Ethernet networks, moving from proprietary operating systems to Windows and Unix, using things like SQL databases and web servers embedded in controllers and so on, which of course is all features that the market wanted and do provide very significant benefits. But one of the downsides is that security was not a significant requirement when most of these systems were developed in that time period. So end users are very dependent on their automation suppliers to help them achieve their goals and of security and securing these products as they're applied in their facilities, and understanding that facilities are using products that may be 15, 20, even older than that, years old. So they're seeking assurance from their suppliers that the products of the level of security that is in the products that you're using today, as well as assurance that the products that they are developing will provide improved or enhanced security features. There are a number of standards efforts in this area to help both the end users and manufacturers implement control system security. The most significant of which is from the ISA 99 committee, who is working together with the IC 62443 to publish a series of documents for industrial control system security. Also important are standards from NIST and NERC, the North American Electric Reliability Council. We're going to focus on the ISA/IEC 62443 for a number of reasons. One, these are industry independent standards, and they are both national and international bodies of work. And this diagram just shows that they are it's actually a series of standards, and they have been written with different audiences in mind. So there are general standards, there are standards for the asset owner, there are standards for the system integrator, and there are standards for the component provider, which is important, again, tying back to this idea of layers of responsibility. For end users, to summarize what's said in the ISA documents in this area, IEC documents, they really recommended strategy for end users is to develop a security lifecycle approach, and to start by assessing existing systems, to document policies and procedures, to train personnel and contractors, to segment the control system networks to provide defense in-depth strategies, to control access to the systems both physically and logically, to harden the components of the systems, meaning to lock down unnecessary unused ports and shut down unnecessary services, and to monitor and maintain system security. So, as I said, a life cycle approach. And you can learn more about this recommended strategy either by reading the ISA 99 documents, or there's also been some very good white papers published on that topic. The recommended strategy for automation suppliers, those that provide the products, is to, again, start by assessing or evaluating existing products, understand where the vulnerabilities in those products are, and perform specific testing to discover those. But also, at the same time, to integrate security into the development lifecycle so that developers who are either creating new products or maintaining existing products are following good, secure practices, everything from requirements to coding to security risk analysis and testing. And to seek third-party certification. And finally, to be prepared to respond to a disclosure, because unfortunately, in today's environment, it's almost inevitable that a security vulnerability will be discovered in a product, and it's important for manufacturers to be prepared to deal with those types of situations. So I wanted to pause for a second, ask another question, and ask if you're aware of any control system security incidents in your facilities or in the facilities of your customers. Give everybody a minute to weigh in. And just to let you, you should be able to see the results now. Still changing a little bit, but as you can see, a pretty good percentage, about 36% are aware of incidents in their facilities or their customers. About half are not, and a small percentage are not sure. So I'm going to go ahead and close that poll. And now we'll turn it over to Graham Speak, who's going to talk to us about the Security Compliance Institute.
Yeah, good morning. As Bob said earlier, although I'm with Yokogawa, I'm also on the board of ISCI. So I'm just going to go quickly through what ISCI is and briefly on the certification, and then John will come back in and give a more detailed view of the device and system certification. So ISCI was formed about 5 years ago, and it is a consortium of everybody, of asset owners, suppliers, and industry organizations. It's under the ISA Automation Standards Compliance Institute, ASCI, and another group under there, which some of you may know, is the Wireless Compliance Institute as well. So both of us are working under this ISA umbrella. And really, it was set up so we could get some specifications out that were well engineered for this industry. And we're looking at specifications and not standards. Or everything that's produced by ISCI, we feed into ISA 99, and ISA 99 standards we take and put into our specifications. And really, it was set up so that for a supplier or automation vendor, we could have one set of specifications that we can develop and design our products to. And as an end user, they can then have one accreditation that they can look at from their suppliers, so they know what kind of security they're getting. As I say, with ISCI, we've got a number of different membership, from strategic membership all the way down to just some people just want information. So as we produce the specifications, we send them out to all our informational members. With the governing board, we've got a mix of two end users, Chevron and ExxonMobil, and then a group of 4 vendors, Honeywell, Inventus, Siemens, and Yokogawa. And because we work very closely with ISA 99, Eric Kosman is the liaison between us and ISA 99. So we both know what is going on, who's producing new specifications or standards, and how we can feed into each other over the course of the year. So in the certification, we have an ISA secure logo. So once a device or system is certified, you get this stamp of approval and this ISA secure logo that you can put onto your products. So what is it? Well, for us, for sort of end users and suppliers, it makes sure that any ICS product that has this logo has gone through some auditable and repeatable approach so that we know what the kind of security is in that product. It's an independent industry stamp for approval. So our ISCI does not do any of the certification. We produce the specifications, and then an independent body will go and do the approval for each of the suppliers. And what we're aiming for is to have it similar to the SIL or the safety and integrity level, which is the ISO IEC 61508, which some of you are probably familiar with. We've actually, although it's under ISA, we've actually teamed up with ISO and IEC and to make sure that this is an international program. Obviously, I'm with Yokogawa, so we're a Japanese company, so we wanted to make sure it was international. The program itself is accredited by ISO IEC Guide 65 Conformance Scheme, which includes the ISO IEC 17025 and 17011 standards. The certification bodies and certification labs are independently accredited, again, nothing to do with ISCI. And all of those ensures you've got the independence of these bodies and these labs. That way the certification is very, very open and credible. So how do you, if you're a supplier, how do you get a device approved? You will go to an NCA class, a chartered lab, and then you go through a three-part assessment. The device itself is physically evaluated for functional security, what we call the FSA. It does a robustness test on the communications, the CRT, and it's using one of the ISCI-approved test tools. And then the actual supplier is audited by the chartered lab on its software development practices. So not only do you know the device itself looks like it's fairly secure, but everything that was built into it was done in a secure, with a good software development lifecycle. And there's a full assessment report and certification upon successful test and audit. What we have, as you can see with the ISA structure that John showed earlier, we've got two parts here. For any component, so any little small device that gets approved, that's then to the 62443-4 series in ISA. And for systems, that is in the -3 series. So benefits of membership for end users. So the certification program has been going on now since 2007, and end users can actively participate in the design and the approving of these requirements. So it ensures that it meets their needs. It also makes sure that for any global and Chevron, Exxon are there, any international requirements those companies have will be included in the certification schemes. And also, if you've got end users who have got a particular industry sector, obviously we're in the petrochemical industry a lot, it'll make sure there's any specific requirements can be included in the certification. And for suppliers, it's very similar. We can ensure as a supplier that anything that gets put in there is practical for the development of our products. And it will meet the international requirements we have. Obviously, I think all the suppliers who are in the ISCI are all global companies selling everywhere. And again, we've all got specific niches in the critical infrastructure, and we can make sure that those requirements are fed into the specifications as well. How you can participate, you can get everything from a member to become an accredited lab or an accredited have an critical test tool. Andre Restaino at ASCI or Bob can help you out. And you can go into the ISA Secure website, www.isasecure.org, and that will give you full details on the program and how you can participate. So with that, I'll pass back to John, who will go through the EDSA and system security programs.
Yep. Thank you, Graham. So as Graham mentioned, there are actually two programs from ISA Secure, the first of which is the Embedded Device Security Assurance Program, or we call it EDSA. And this was made available in 2010. And the other is the System Security Assurance Program, which I'll talk about momentarily. But first on the embedded program, this is focused on embedded devices, the actual products or the building blocks, if you will, of control systems. And is focused on these types of devices, anything that is running embedded software that can directly monitor, control, or actuate an industrial process is considered an embedded device and can be evaluated and certified. So examples of that would be PLCs, DCS controllers, safety controllers, intelligent electronic devices, IEDs, protective relays, motor controllers, SCADA products, either the controllers or RTUs, turbine control, vibration control, compressor control, and that's really just a partial list of the types of products that can be submitted for this program. Graham also mentioned briefly the main components of the program. The idea of the EDSA certification is to take a holistic look at a product to evaluate its security. And the three main components are a testing component to test the actual resiliency of the communications interface on the device. And we call this CRT testing. And this is meant to identify the vulnerabilities in the network interfaces in these devices and make sure that they are robust against common known types of attacks that could affect an industrial control system product, either denial of service type attacks such as storms or malicious attacks with malformed packets and deliberate attacks to spoof addresses, to send malicious communications to try to affect the response of the controller. This can be very effective at finding these types of vulnerabilities in these products, but testing alone is not sufficient. You can only test for a certain number of conditions and known vulnerabilities. So on top of testing is the other layer, what we call functional security assessment. And this is actually looking at the security features and functions that are available in the product and evaluating them against a set of requirements that was largely derived from the ISA 99 body of work in terms of the types of security features that are expected to be found in these types of devices. Things having to do with access control, how users are identified and authenticated, the types of privileges that are available through the network interfaces, how data is, the integrity of data is maintained and the confidentiality of data is maintained, and so on. And the third layer is also an extremely important layer, which is looking at the development process that the manufacturer followed in designing and developing and maintaining, particularly the software in these embedded environments. As we all know, the most security vulnerabilities are software related, and so the vendor software development and maintenance process is very important. In fact, I'm going to talk a little bit more about that portion, what we call the SDSA, the Software Development Security Assurance. Just to let you know that the source for this or the sources for this are many. because software security assurance is not necessarily a new field. The objective here is to take these best practices and develop a set of requirements that are applicable for industrial control system products. So a number of different sources were referenced, everything from the Microsoft Security Development Lifecycle model to Build Security and Maturity model, something called BSIM. Also IEC 61508, the functional safety standard, has requirements around software development. Something called IEC 15408, also known as Common Criteria, and even an aviation standard, RTCA DO 178B, was used. The objective of all of these is to incorporate security into the software development lifecycle. So while all products go through a normal software development lifecycle, as shown here with this, what we would call a classic V model, but this can be applied to any development lifecycle. It's the items around the outside that I've added are the security-specific elements that were added to this evaluation that we call SDSA. So everything from making sure developers have been trained to the fact to writing security requirements, to incorporating security into the architecture design. A very important part is security risk assessment and threat modeling to identify the vulnerabilities systematically, to having secure coding guidelines, making sure developers are following those, secure code reviews by peers and static analysis to find common coding vulnerabilities, to additional efforts around testing, particularly fuzz testing and abuse case testing, and security validation testing, and finally security response planning and execution. So all three of these come together to form the ISA Secure EDSA certification. There are three different levels of certification that a product can achieve, and the idea here is because, number one, not all applications require the same level of security, and also not all products are capable of achieving all levels of security. The program basically breaks it into three levels, level 1, 2, and 3. And you can see here there is increasing levels of rigor applied particularly to the FSA and the SDSA portions of the evaluation for level 2 and level 3. The communication robustness testing actually is consistent across all three levels. The additional level of rigor has to do with the requirements for the functional security assessment. For example, the level of data integrity protection from level 1 to level 3 varies between, at level 1, there's requirements that the communications not be in clear text, whereas at level 3 it requires that communications be encrypted. So that just an example of the types of differences between these different levels. This whole program was meant to be very transparent, so the actual specifications are available for download, and anyone can go out and read the requirements and actually see how every single requirement has been assigned to a level. Another thing to point out is that, of course, there are many companies that develop multiple products, and so the program was designed to accommodate that, allowing for a development organization to get their software development process independently certified, and then they can also then assess individual products against that software development process. So this is meant to illustrate how a single vendor can have multiple products certified and also get their software development process certified. Often a question comes up about the relationship between ISA Secure and the Achilles Communications Certification Program. A couple of years ago, ISA Secure and WorldTech reached a cooperative agreement. There's a press release that you can read on the ISA Secure website about this agreement. WorldTech operates the Achilles Communications Certification Program, which is focused on communication robustness testing or network robustness testing. And a couple of years ago, the WorldTech and ISA Secure came to an agreement that Achilles Level 2 would meet the ISA Secure EDSA CRT requirements. So they've been harmonized or reconciled. And so actually the Achilles satellite Level 2 is one of the recognized test platforms for communication robustness testing. So you see there is a relationship between the two in the sense that the Achilles communication satisfies the requirements of the communication robustness testing portion of ISA Secure. To date, there are 4 products that have been certified through the ISA Secure EDSA program. The Honeywell Safety Manager, the RTP Corps Safety System, RTP 3000, and also Honeywell recently got their DCS controller and field bus controller certified. Obviously, there are other manufacturers that are going through the process right now with various different products, but until their certifications are complete, that can't be announced. I also quickly want to go through where ISA Secure is going in terms of the developing the next level of the program, which we call the System Security Assurance Program, or SSA. The idea here is to move beyond just the devices that we talked about in the EDSA program and look at control systems that are available from suppliers. Things like packaged control systems and control system platforms are the scope of this type of assessment. So the kind of system that you can purchase from a supplier that's been integrated as a system. So, for example, here this would be a type of system that would be considered. It may have one or more embedded controllers, and of course one or more computers for engineering and configuration. It could also have servers and historians and a variety of different equipment that make up that system. And so it's very important to first identify what is the system that's being evaluated. And of course it has networking components. Then the system will undergo a very similar 3-phase assessment as we talked about for embedded devices, but of course now looking at it as an entire system. So like the other program, there's a robustness testing portion that's focused on the actual resiliency of the system as implemented, identifying vulnerabilities in the actual implementation through a combination of structured penetration testing at all the entry points, scans for known vulnerabilities, and also a repeat or additional communication robustness testing. The system will also be evaluated for functional security, again, using the requirements from the ISA 99 series of standards that specify how systems should respond, other features that should be available for access control, use control, data integrity protection, data confidentiality, and so on. The System Security Assurance Program is not quite ready yet. It's still under development, but is expected to be released in the 4th quarter of this year. So before I turn it back to Graham to wrap things up, we wanted to ask one question. Do you see benefit in independent security certification of devices and systems? And I'll let you see the results here. It seems to be a pretty overwhelming response here for yes, or at least maybe. All right, I think I'll go ahead and close the poll. Thank you for letting us know your thoughts on that. And now I'll turn it back to Graham to wrap things up.
Okay, so in the last few minutes, what I'll go through is what it means both to suppliers and end users. And although I'm sort of with a supplier at the moment, and I've only been with Yokogawa a couple of years, before that I was over 10 years with an big end user asset owner. So I can probably do both sides of it and give you the benefits for both. I mean, certainly from a supplier, I mean, it will improve the quality of our products. I mean, if we've got a nice international industrial standard that we can use, we can base our new products on that and make sure that we build security in. And we're finding that it's got applicability both to our vendor product and actually to the processes that we go through to actually develop those processes. And more, I mean, I think it started a few years back, but certainly over the last 2 years, more and more now of our customers are coming up and saying they want to have a more secure product and they want to have security built in, because as we all know, if we sell a product today, it's likely to be in an end user for, perhaps not 5 years, but 10, 15, 20 or even more years. So we need to make sure that there's as most secure as we can get when we deliver them. And for us, it's getting an independent assessment against those requirements so that we know it's not just our view of the products we're developing, it's we're actually getting the stamp of approval from an independent body. These are some typical changes that have been driven by the certification process. And this has coming from the people who've already got the assessment certification and people who are going through it. Certainly, we're all looking at our software development lifecycle and reviewing it and making sure that it's up to date. You've got to keep looking at your SDL and making sure it's going to be continually updated as new thoughts come along. It's certainly driving all of us to make sure that we keep updating our security training and making sure that we do that training for our development and test teams and that everything gets that everybody gets the up-to-date training. Certainly all of us, all manufacturers, we've got multiple development locations. So we're all making sure we have security experts in each of those locations such that we can help out the development teams as it goes along. Quite often we're needing to update some of our security documentation, make sure it's up to date, make sure it's following these new specifications. One of the things we've probably all gone through is making sure that we do our risk analysis and threat modeling. And we probably are all doing that, but yes, this is certainly making sure that we've got a much more increased view of this. Certainly on each individual product, where there's more denial of service and testing now going on an ongoing basis, so not just as a product is finished and gone through the final test, but as we're developing it. And we're also tracking security issues to make sure that, if we find one issue in one of our products, we can check all our additional products, making sure we haven't got the same issue, so that we're improving the security of everything as we go along. And certainly from an end user, certainly when I was an end user, for us, as an end user, we want to look at getting certified products that we knew what the level of security was. To actually grab a product from a supplier that said, right, it's had the stamp of approval ISA secure, we know what kind of process the supplier went through to get that certification. So we really know that that is a very secure, or as secure as it can be, device up to when it gets delivered to that end user. So briefly, as a wrap up on some of the benefits for the certification. From an end user perspective, easy to specify. An end user can just say, I want an ISA secure device. And that's all they need to put into the RFP. They don't have to put in very complex security requirements. Certainly then in the FAT and SAT testing, it's easier. You don't have to test every component. If you've got a component that is an ISA secure component, it's had all the fuzz testing, all the communication robustness testing, etc. You don't have to repeat that in the FAT and SAT. It will reduce the time, and therefore you can get through that process a lot quicker. And you know the security level of each of those devices when it comes out of the box. You don't have to retest them. Certainly from a supplier perspective, we can evaluate the product once. We don't have to go through 2, 3, 4, 5, 6 different certifications. If we've got an ISA secure certification, we can show that to the end user so they know what kind of security we've got built in. Certainly recognises us for the effort, so yeah, we can promote that as a differentiator from our products as perhaps some others who haven't got it. It certainly makes us build security in from day one, from the very early R&D phase all the way through to the product when it gets released and beyond into the maintenance phase of those devices. We'll reduce our support costs because we're using the same process for all our products, and therefore that's going to reduce the ongoing support. And it enhances our credibility. So, what we're seeing is, this will give us, as a supplier, yes, we're building the security in, and from an end user, you're getting more secure products as we go along. And for that, who to contact to certify products? So if you are a supplier of automation products, Exeter you can go to, and John, and there's his information. And if you're interested about ISCI membership, or if you're interested in ISCI as a whole, you can talk to either Andre or go to our website, and that's got all these contact details. You can also contact some of the other board members and either an end user or supplier and get their view of why they have joined ISCI and what they think their benefits are on an ongoing basis. So I think that wraps it up. We're trying to give 10 minutes at the end for question and answers, so perhaps hand it over to Bob, see if he's actually got any questions that either John or myself can answer as we go along, or if we run out of time, we'll make sure that we email everybody the Q&A.
Great. Thanks a lot, John and Graham. And just so everyone knows, we have recorded this webinar, and we'll post it to the ISCI website, and we'll send a link to that as a follow-up to everyone who attended and those who signed up and couldn't attend with us today. You should have a Q&A menu item at the top of your window. If there are any questions, you can type them in there, and the presenters can respond to those.
I see we have a question here. It says, how will ISA secure certified embedded devices deal with new viruses that come every day? That's a very good question. As we all know, the threats to control systems change on a daily basis, or cyber threats in general change on a daily basis. And so how would a manufacturer deal with that, and what does that mean for the certification? The certification, of course, is an evaluation of a product from the testing standpoint. Is at the moment in time that it was tested, but that's actually why there are two other parts of the program, because testing alone was felt to not be sufficient. That particularly the software development lifecycle process that's required makes sure that manufacturers have processes in place to monitor for new viruses and threats to their control systems, to update their threat models, to create a threat model and to update it as appropriate based on changing conditions, and to manage the vulnerabilities that are discovered, both in terms of notifying their customers but also releasing timely patches. So that's why the process part of this we felt is so important, because of course you buy a product at any given time, but the threat environment can change, and therefore it's incumbent on the manufacturer to stay on top of that and to make necessary corrections to the product, which is all part of the software development lifecycle process.
Yeah, and we had one other question, but I'm not quite sure. It said, how much response we received till now from supplier end user for certification? I'm not sure if I understand the question, if you do, John.
I think it might be asking the level of interest, maybe, from suppliers and end users.
Oh, yes. I mean, certainly from us. I mean, in the petrochem industry, we're certainly seeing a number of end users saying they are looking to put ISA Secure into their RFQs this year and next. Yes, so some people are. We have seen one or two instances where it has actually been in an RFP. Not saying they want a ISA Secure certified device, but just asking the question of, are your devices certified to ISA Secure? And I think as more devices, and as John said, there's at least 4 going through the process at the moment. As more devices get certified, I think towards the end of this year and perhaps next, there's certainly going to be a drive from a number of end users saying they will be looking at ISA secure devices, particularly in certain areas. If they've got a high criticality application, I'm sure they're going to be asking for that. So yes, it's coming. It's slow at the moment, but that is sometimes due to only a small number of devices being actually certified.
Yeah, I can add to that the level of interest from automation suppliers is quite high, but most automation suppliers right now are looking at their software development lifecycle process and looking to enhance it for security, and that can be a lengthy process for companies because it takes time to change these processes and implement those changes. While these companies are working towards updating and improving their security lifecycle processes, they're also getting started to get their devices evaluated and tested. So it can be a little bit of a lengthy process. It depends on the level of maturity of the organization around security software development. But as I said before, there are most major industrial automation suppliers are at least looking at the program and looking internally at their development processes to see what changes need to be made to enhance those.
There's another one. How often do you recommend recertification? I think from a supplier point of view, we may change or put updates to a product over a year, but major, the new devices or major enhancements don't come around as often as perhaps other software development systems, and I think it'll depend on what the device is and where it's going. You're probably not going to recertify these every quarter or every half year, perhaps not even every year, but you might be looking at perhaps a 2-year process where you'll have done enough major changes that you want the recertification. And quite often we've got it built in, so you don't have to recertify totally and redo everything. So if you've only changed certain things, you can go to the test lab, tell them what you've changed, and if they agree, they will only recertify or retest the bits that you have changed. So it's not a complete recertification, or may not be every time.
Mm-hmm. There's actually the program itself has a very comprehensive document describing the maintenance of certification and what would trigger a recertification, either a change in the product, a change in the spec, or the desire to achieve a higher level of certification. Another question here about how long does it take for a typical certification of a device. It certainly varies, but I'd say probably on average at this point it's running about 6 months from start to finish.
John, I'm going to go back to show the contact information for ISKI.
Mm-hmm.
There's been questions about how to get in touch with ISKI, about membership,
mm-hmm.
And ISKI is very interested in having additional members help guide what the certification is, how it works. So individuals and companies are invited to be part of ISKI, and we can send out more information about that.
Great. I see a question about interaction with the U.S. DHS National Cybersecurity Division's Software Assurance Directorate. Maybe a better question for Bob to address, but one thing I could say about that is that the program has been discussed with a lot of different government agencies, U.S. DHS in particular, but I know that the government organizations like that are not allowed to provide any particular endorsement for programs like this, but they certainly are aware of them.
Yeah, and I don't have anything to add to that.
Okay.
Okay, I think we've covered all the questions, and it's 12 o'clock. So I want to thank our presenters, John Cusimano and Graham Speak, and thank everyone for attending. The contact information is there for ISKI if there are any further questions, and we'll also be sending out a follow-up email. It will have a link to the recorded session and more information and links to ISCI. So thank you very much to everyone, and we will have future webinars on similar subjects in the future, so we'll be sending out email about that also.
Great. Thank you, Bob. Thank you, everybody.
Yep. Thanks, everyone.